Okay, good evening. Welcome all to day 3 of this electrical safety specialist course. In the last session, we discussed about a different type of the boundaries, uh, which is covered in NFPA 17, like sh shock protection boundary and the arc flash boundaries. And we discussed that the shock protection boundary is further divided into the restricted approach boundary and the limited approach boundary. Right. So what this restricted and limited approach boundary triggers? Limited approach boundary basically triggers that beyond this point there is an electrical hazard, and the chances of and the electric shock hazard exists, and the chances of getting electrical shock is there. So now unqualified person should cross this boundary unless and until he is escorted by the qualified person. Second is that no ladder, no long tools, scaffold, and other things should be bring within the limited approach boundary. So, for example, if you are working at overhead line, or if you are operating crane, so the crane should keep a minimum distance of limited approach boundary. If they are operating near some overhead line, that distance is covered in the standard. So this distance can be used for a person who is working near overhead line, or any machineries or any equipment which is being operated. So for example, if any crane is being operated at the overhead line where the voltage level is 275 kV. So here it says 242 kV, and the next one is 345. So 275 will going to lie somewhere here. So we have to keep approximately 15 feet and 4 inches away the maximum beam of those operating machines. If it is operating at 400 kV, so 400 kV is not there, so we will going to use this one. So what should be the limited approach boundary? Limited approach boundary should be 19 feet and 0 inches. So normally in other type of the courses, like in NIBOSH and other, I think they kind of they have keep this distance as constant of 10 feet, if I'm not wrong. So but here it says that the limited approach boundary will going to increase as the voltage will going to increase. Right. So another thing, this is for the limited approach boundary, and for the restricted approach boundary is it basically triggers that only qualified person can enter the restricted approach boundary, and when he is wearing the personal protective equipment rated for that voltage level. So here we are talking about the restricted approach boundary. So the PPs which we are talking about is related to shock protection. We are not talking about personal protective equipment related to arc flash right now, because the arc flash boundary can come inside the restricted approach boundary. We will going to see those examples shortly. So in exam, when they will going to ask about the restricted approach boundary, you have to keep your focus that the restricted approach boundary is for qualified persons only. No unqualified person can enter this boundary in any case, or under any situation. And only qualified person will be within this restricted approach boundary when he will be wearing appropriate personal protective equipment rated for that particular voltage level. When in exam, the question will be about the arc flash boundary. So within the arc flash boundary, we have to wear an appropriate arc rated clothing. Okay, so the arc flash boundary can come within the restricted approach boundary, it can come within the limited approach boundary, or it could be away from the restricted as well as the limited approach boundary. Any questions up till now, what we have covered in last two sessions before proceeding?
Sir, if the MDB board is open, then the restricted area, boundary area is coming.
Yeah, if it is open and energized, then this limited approach boundary, restricted approach boundary, and the arc flash boundary exist. But if you have established an electrically safe work condition, And that means you have fulfill all the requirements of Article 120.5. Now there is yani all those boundary does not exist. These boundary exist for life work.
Okay, sir.
Okay.
Okay, sir.
Yeah, for recorded lecture, you have to talk to Mr. Salahuddin Johar, because now it is being sent to him, and he informed me that he might be directly dealing with those administrative things.
Okay, sir.
Okay, so moving forward for the arc flash hazard, it's a source of possible injury or damage to health associated with the release of energy caused by an electric arc. So this is the definition you will going to find in Article 100. What's an arc flash hazard? It's basically a source of possible injury or damage to health, which is associated with the release of energy caused by an electric arc. So electric arc could be caused due to human error, or it can cause due to equipment failure. So due to this electric arc, and energy is released, and the temperature can rise up till 5,000 degree centigrade, or if you talk about in Fahrenheit, so it could be 35,000 degree Fahrenheit. It can reach. Time for an arc flash is less than 5 milliseconds. Intense light sound wave is greater than 140 decibel. Pressure wave is also released. Sharpness and mortal metals are also released during this course of action. So the likelihood of occurrence of an arc flash incident increases when energized electric conductor or circuit parts are exposed. So let's start with the first part of this conversation, that the likelihood of occurrence of an arc flash incident increases when the energized electric conductor or circuit parts are exposed. So if the electric conductor or circuit parts are already in an electrically safe work condition, that means you have eliminated the hazard. So if you have eliminated the electrical hazard, so nothing is associated with the arc flash or shock hazard is there. Only if the energized electric conductor or circuit parts are exposed, then this arc flash hazard exists. Or when they are within the equipment in guarded or enclosed condition, provided a person is interacting with the equipment in such a manner that could cause an electric arc. Now, it is closed inside the enclosure. The enclosure is closed, but I'm operating it remotely or locally. So if I'm interacting with the equipment, so there is a chances of flashover is there as well. Okay, so likelihood of occurrence is there when I'm interacting with electric conductors or circuit part, even they are enclosed. If they are enclosed and I'm not interacting, still there is a chances of flashover is there due to equipment failure, but that does not come under the jurisdiction of NFPA 70E, because you are not interacting with that particular equipment. An arc flash incident is not likely to occur under normal operating condition when enclosed energized conductor has been properly installed and maintained. So this is the point which I'm talking about, that under normal operating condition, if the equipment is running, and I'm just bypassing, or I'm just crossing that particular area, or or no one is performing work on those particular equipment. So the likelihood of occurrence under normal operating condition is not likely if the equipment is properly maintained and was properly installed. Okay, so this is basically the responsibility comes under NEC and NFPA 70P. Installation requirement is with NEC, which is NFPA 70. Maintenance requirement is with NFPA 70P. So if NFPA 70B and NEC have already been implemented as a part, so the equipment on which you are not performing any job should not cause you any issues. Okay. Yes. Any question on this slide, or any further clarification required? Please confirm.
No, sir.
Okay. So what is normal operating condition? In order for an equipment to be under normal operating condition, it should have these 6 requirements to be fulfilled. These 6 requirements, if these 6 requirements are fulfilled, then we will term as that equipment under normal operating condition. The equipment is properly installed in accordance with manufacturer recommendation and applicable industry codes and standards. So the equipment was properly installed as per the manufacturer recommendation or industry codes and standard. The equipment is properly maintained. So equipment is properly maintained whether the organization is following NFPA 70B or any other industry codes and standard. Third is that equipment is used in accordance with instructions included in the listing or labeling and in accordance with the manufacturer's instructions. So the equipment are being used as per the instructions given. Okay, so for example, if it what is mean by the equipment is used, for example, if the manufacturer says that the equipment should not be operated overloaded, like for example greater than 50% load or the 80% load. Okay, so that means it requires equipment is following the manufacturer instructions. For example, there is a requirement that those equipment should not be operated under load condition. Okay, so and what is mean by load condition? There is a switch gear which you cannot operate on load. First you have to remove the load, then you can switch it on and off. So this is one of the manufacturer recommendation about the operation of those electrical equipment, because maybe during live operations or operating at load or unload loading and unload criteria, it might cause arcing, which might reduce the degradation of the electrical equipment quickly, and it can shorten the life of the electrical installation itself. So equipment is used in accordance with instructions included in the listing and the labeling. Okay, another example could be, for example, if I have isolators cannot be operated on load. First I have to switch on the line, then I can operate those isolators. If I going to operate those isolators on the live, then it will going to cause it can cause serious hazard. Fourth is equipment doors are closed and secure. So all the equipment doors are closed and secure. There is no doors are open when I am interacting with those particular equipment. Equipment covers are in place, back plate or the front covers are in place. So there is no chances of any rodent or any other external like rats, cats can enter into the electrical equipment, and when I am operating those equipment, it might cause flashover. Last one is there is no evidence of impending failure such as arcing, overheating, loose or bound equipment parts, visible damage or deterioration. So final thing is related to the impending failure. So impending failure in the maintenance and reliability, it is also called potential failure. Yani equipment has not failed, but there is a probability that it will going to fail, or any failure or the fault have started in the equipment itself. For example, if there is a puncture in a tire, so that puncture is basically the impending failure or the potential failure. With a puncture tire, you can go 1 kilometer, 5 kilometer, 10 kilometer, or that puncture might be so severe that you cannot drive your car 1 inch. So in that particular case, when you are not being able to drive your car any further, that potential failure has converted into the functional failure of the equipment, that now you cannot perform the function for which the equipment was actually used for. So similarly, what's the impending failure could be for electrical equipment. There is some overheating, or there is some vibrations in the equipment, which is basically giving you an indication that some fault or the failure is developing in the equipment. You are operating, the equipment is running and providing you the required result, but it is causing you though it is basically indicating that the fault have started to develop within the equipment. Yes, Mr. Jansi.
Sir, to secure our equipment in the circuit, we have these circuit breaker and these elements. So these are not enough for impending failure.
Basically, what is impending failure? For the circuit breaker, for example, circuit breaker has started to deteriorate itself. Their insulator have started to deteriorate itself. So there is some insulation failures have started, but those are not severe enough that it will going to cause flashover, or it is maximum amount of fault current is passing. So it has started failure is there, but it is not might not be that much visible, or it has not reached up till that quantity that it will going to from the potential failure, it has reached towards the functional failure. Let me take you to one of the diagram, then we will come back. Just a second. Yep. For example, in any electrical equipment or cable, its insulation has started to deteriorate. So there the potential failure have started, but that insulation has not damaged up to that extent that it will going to cause a short circuit and the failure of that cable. So it will going to follow this type of the curve. The start of this decay curve basically highlight or indicate the impending failure or the potential failure, and this is the point at which the failure actually happens, and it basically shut down the system or the equipment. So before reaching to this point, there are number of indication which electrical equipment or any type of the equipment, for example, in your car, you start to hear about bearing sound. So that starts to indicate that the bearing have started to deteriorate, or there are some failure have started to happen in your bearings. So those sound vibration will going to indicate that something is there. So that is basically the impending failure. But if you keep on driving your car with the bearings slightly damaged, then it will going to break it fully, and it might cause a serious incident. So that is basically the point from here to here. For electronics equipment, this curve does not follow. Electronics equipment is like this, a straight line going down. Then for example, for bulb or any electronics equipment which we are using, so those electronic equipment does not follow, most of them does not follow this curve. They are strictly like this. If the fail happened, then it will be basically it will convert into the potential failure. Yes, Jazib, am I able to answer your query?
Thank you, sir. But for you know some devices to prevent impending failure in real time.
Yeah, for example, thermography. We are performing to identify that there is some if there is some hotspot there. So that will going to indicate that there is overloading is being is there, and there is ultrasonic discharge testing, and the TUV testing, which is one of the product of EA Technology UK. So those are basically being used to identify those thing, right? So basically these are being used or different type of the electrical test are being also used? Okay, so if all the six conditions are met, that the equipment is properly installed in accordance with the manufacturer recommendation, the equipment is properly maintained, the equipment is used in accordance with the instructions, equipment doors are closed and secure, equipment covers are secure, and there is no evidence of impending failure such as arcing, overheating, loose or bond equipment part, visible damage or deterioration. So if these are not the case, then the equipment will be termed as is in the normal operating condition. Otherwise, operating those equipment, there is a chances of failure is there. Okay. Right. So arc flash incident from the initial fault to the expiration of the arc is there. An arc flash incident can result in intense heat, sharpnel, mortal meltdown, intense light, poisonous oxide, and the pressure waves. So if this person is performing any job here, he is just operating that particular equipment. So there is some impending failure, might be impending failure within the equipment itself, and he does not know. So how you can determine the impending failure, or how you can determine whether this equipment is under a normal operating condition or not? So if the equipment was properly maintained, or the equipment was properly installed or not. So maybe this equipment have not been maintained over the period of time correctly, and there have been impending failure developed in that particular equipment. And when this person operated this equipment, so that equipment basically failed in such a way that it causes an arc flash. So determining the equipment under normal operating condition, it's a challenge. 70E does allow that if you have determined that the equipment is under normal operating condition, you can just operate those particular equipment. Then there is no requirement of wearing any personal protective equipment. There is no requirement of arc flash boundary as well. So this concept will be tested in exam, that if you determine that the equipment is under normal operating condition, so the chances of arc flash is not there. When the chances of arc flash is not there, so there is no requirement of PPs, there is no requirement of arc flash boundary. But it is very difficult, or it is nearly impossible to determine whether the equipment is under normal operating condition or not. So that is one of the dodges there. From the exam point of view, I recommend that keep this point in mind. But when you will be developing your own electrical safety program for your organization, you should not consider this thing in your electrical safety program, that there is some cases of normal operating conditions are there. So now we have in the previous class we saw the limited approach boundary, restricted approach boundary, and now the arc flash boundary. So the arc flash boundary normally shown as the outermost boundary, and then the limited approach boundary and the restricted approach boundary. Just keep in mind that the relationship between the restricted approach boundary and the limited approach boundary is constant, that the restricted approach boundary will always be the inner side and the limited approach boundary will always be the outer side. For this arc flash boundary can come within the limited approach boundary, or it can come within the restricted approach boundary, or the arc flash boundary could be the outermost. How arc flash boundary can change, we will going to discuss shortly. The limited approach boundary and the restricted approach boundary is dependent on the voltage, but the arc flash boundary is dependent on the incident energy. So what is incident energy and how it is calculated, those we will going to see shortly. The arc flash boundary is an approach limit from an arc source at which an incident energy equal to 1.2 calories per centimeter square. It is the boundary at which the second degree burn on unprotected skin can occur. Within 1 second, the arc flash boundary is determined either through calculation or through the use of PP category method given in table 130.7. C15. So note the arc flash boundary may not always be the farthest boundary. We have to keep in this mind that the arc flash boundary will not always be the farthest boundary. It could be within the within this boundary as well. Right. So here in this definition, you can see that the arc flash boundary is an approach limit for an arc source at which the incident energy is equal to 1.2 calories per centimeter square. So at this point, we are actually my equipment is there. In case of any arc flash event occurs, the incident energy will be high because at that particular point or at that particular location, high amount of incident energy will be released. As I move from the center or the point from where the arc flash initiated, it will going to decrease over the period of time. So maybe at this point, the incident energy, just keep in mind that the incident energy unit is in calories per centimeter square, which is basically the unit for some energy which is impacted on a human body. So as we move from this center, the incident energy will going to decrease over the period of time. Here it could be, for example, 30 cals per centimeter square. Here it could be 20 cals per centimeter square. Here it could be 40 and at a distance, here it could be 15. So it is decreasing over the period of time and a distance at which the incident energy is equals to 1.2 calories per centimeter squared. That is basically the distance at which we have to draw our arc flash boundary. So at the arc flash boundary, the incident energy will be equal to 1.2 calories per centimeter square. So how this incident energy is determined? So there are two methods given in the standard. One is the PP category method, and the another one is the arc flash incident energy method. Those methods are being used to calculate those incident energy. So what is incident energy? The amount of thermal energy which is impressed on a surface at a certain distance from a source generated during an electric arc event. So incident energy is basically the thermal energy, which have the energy calculated in calories per centimeter square. So this is basically the amount of thermal energy which is impressed on a surface. What is surface here? Surface here is human body. Okay, so the amount of thermal energy which is impressed on a surface a certain distance from a source. Source is what? The source is basically the electrical equipment, and within that electrical equipment, the bus bars or the energized part from where the energy will be generated or radiated. So the amount of thermal energy which is impressed on a source on a surface a certain distance from a source generated during an electric arc event, which is basically generated during those electric arc event. Incident energy is typically expressed in calories per centimeter square, cals per centimeter square. The science and the testing have proven that 1.2 calories per centimeter square is sufficient to cause a second-degree burn to expose the skin. Incident energy calculation are based on thermal energy only. So basically 70E is not allowing us to receive a second-degree burn, but it has put 1.2 calories per centimeter square as a method for testing, as a method for identifying that the risk associated with that particular hazard is now significant, and we have to take control, or we have to put some control, and we have to take some action. Okay, so for this particular reason, we have to be careful in the exam that 70E is not basically allowing our employees to be exposed to 1.2 gals per centimeter square. It is basically providing us this information that this is the level of the incident energy at which a second-degree burn can occur, and in order to protect your employee, you should not expose your employee to 1.2 cals per centimeter square of the incident energy. So the science and testing have proven that the energy is sufficient to cause a second-degree burn to an exposed skin. Predicting the amount of available incident energy is crucial when selecting the appropriate PP. So how we will going to predict the incident energy? It will be predicted either if we are using an incident energy analysis method, or if we are using the method by the PP category method. So the PP category method does not directly provide you the incident energy, but it refers to the category level which you need to wear in order to protect yourself from the energy level. So properly rated PP can prevent injury, melting or burning of clothing, and direct skin exposure due to increased temperature during an arcing event. Using PP rated above the calculated incident energy value can increase the probability that the employee is protected from injury. So at particular location, if the incident energy is 8 cal per centimeter square, so it is advisable that you should wear the PP of rating 10 cals per centimeter square or 12 cals per centimeter square in order to keep yourself safe, rather than you are wearing personal protective equipment PP exactly equal to the rating of the incident energy available at that particular location. So what is basically the second degree burn? The second degree burn is also called a partial thickness burns are possible on unprotected skin from exposure to arc flash. So there is no LTI in if a person is exposed to an second degree burn. This is basically repairable and it's manageable, maybe by normal dressing or attention. He can resume work. So but 70E says that you have to protect your employee against the second degree burn. So 1.2 cal per centimeter square is an important incident energy level threshold for arc flash hazard management. If you are developing an arc flash hazard management program in your organization, you have to take care and you have to develop your arc flash hazard management program based on this level of the exposure. So how this incident energy is basically calculated? The method is called incident energy analysis method. So this method is basically the component of an arc flash risk assessment, which is used to predict the incident energy of an arc flash for a specified set of conditions. We use different softwares, or you can use mathematical models in which you are basically modeling your electrical network. This is from the supply which is coming. This is a transformer. From transformer there is a bus bar, and from the bus bar those are basically the breakers installed. From the breaker we are operating a motor, for example. When we will going to model this network in our softwares or like ETAB or SKM or any other software, and we will going to add the parameters, what is the length of the cable, what's the diameter of the cable, what's the available short circuit is there, etc., etc. Then it will going to calculate the incident energy at that particular location. So here it says that if you are operating this particular equipment under this set of operation, a specified set of operation, the incident energy here will be 30.8 cals per centimeter square at 18 inches working distance. So arc flash boundary, it should be 139.9. If you are operating this, so these are examples. This is for examples only, just to clarify the concept. If you are operating switch gear at the low voltage side of the transformer, so at this particular location, the incident energy is 18.7 cals per centimeter square at the working distance of 18 inches, and the arc flash boundary will be 99.6 arc flash boundary. Okay. So at other location, the incident energy will be different based on the location. So for a complete industry or a complete location, the incident energy will not be same. It will be different from one place to another place. Okay. The calculated incident energy from the installed specify assessment is predicted energy an employee will be exposed if the R flash incident occurs. So what is mean by this is specified set of condition. For example, I might have two generators in my system. I can connect both the generators together, and they are running in parallel. Under this set of condition, the short circuit and the incident energy will be higher at this particular location. If I'm operating my system and with only one generator on, the overall fault of the system will be low. So in that particular case, the incident energy could be low there. So basically, we will be analyzing our network with a different set of condition, a specified set of condition, and we will be predicting what will be the incident energy for different combination. Maybe we are operating our system at full load, no load, half load, etc. So we will be analyzing systems for different angles, for different set of condition. The maximum amount of incident energy which will be available in our system, that we will be using for labeling purpose, not the minimum one, or we will not be using multiple labels. No, we will be using worst case scenario. Under any condition in which the incident energy is maximum, under that condition in which the incident energy is maximum, we will be using that particular scenario. Is any questions up till now?
No, sir.
All good. I will be giving a quick review of what we are discussing up till now once we have completed this R flash topic. So now we know about the incident energy, that it is basically the thermal energy which is impressed on a surface. And what is the surface? It could be human body, or it could be any equipment. But here we are trying to protect the human beings. So this surface is, we are considering this surface as a human body at a certain distance from the source. So we have also understood that the incident energy will going to decrease as the distance increases from the source. So a distance at which the incident energy is equal to 1.2 cals per centimeter square is basically the distance, or it's basically the distance of an R flash boundary, right? Then how this incident energy is calculated, we are basically performing an incident energy analysis, which is a component of an R flash risk assessment used to predict the incident energy of an R flash for a specified set of conditions. So if an R flash happens in this one, what will be the incident energy? If the R flash happens in this at this particular location, what will be the incident energy? So incident energy is dependent on many factors. It is dependent on voltage. It is dependent on the system configuration. It is dependent on the bus bar spacing. It is dependent on the amount of available fault current and the clearing time of those protective devices. So how quickly the protective device will going to clear those faults. Some things, most of the things are not under our control for a already built network. For example, if I am now been appointed as an HSCQ manager or the engineer for a particular site, for that particular site, it will be difficult for me to change these things: voltage level, system configuration, bus bar spacing, the amount of available short circuit current, because it is already installed, it is already built, the network is already built. So I have left with very few options. Either I can change, I can play with decreasing this short circuit current in this particular location, or I can play with this fault clearance time. Changing this available fault current is required expensive solutions. So you will be installing a different type of the electrical equipment, or you will be changing the network configuration, topology, etc. What is easy to do is to play with this fault clearance time check whether your fault clearing time of those protective devices are okay, or is there anything which you can do with it. Maybe there are certain breakers which are bypass, or in certain protective devices the uh, uh, it is like that they have not been configured correctly. So it gives an opportunity to review your protection design, protection settings, and do your job accordingly. So the amount of clearing time is directly proportional to the amount of heat. The incident energy is calculated in calories per centimeter square. The PP is also rated in cals per centimeter square, but it is either ATPV or EBT. We will going to discuss what is this ATPV and EBT. So incident energy is directly proportional to the time. So the greater the amount of time, the greater will be the incident energy. For example, at a particular location in my system, I basically designed my electrical equipment or the system based on the device clearing time of 0.1 second, for example. So the incident energy will be 5 cals per centimeter square. So this was my design. But over the period of time, after 5 years, the equipment was not maintained correctly, and due to poor maintenance, the device clearance time and the operation time of that particular equipment increased from 0.1 to 0.4, 0.5, or 0.6. So at that particular location, 4 years back or 3 years back, I performed that that complete risk assessment of my system, and I determined that the incident energy at this device clearance time is 5 cals per centimeter square. So I performed the risk assessment and put the labels there. So since then, all the people who have to perform the switching operation or have to perform some justified work on those electrical piece of the equipment know that if I'm wearing 8 cals per centimeter square or the 12 cals per centimeter square suit, that is safe for me because the incident energy at that particular location is 5 cals per centimeter square. But the equipment has not been maintained, or maybe the protection settings have changed and no one have taken the notice. Now at that same location, the device clearing time has reached to 0.4 or 0.5 seconds. So at that particular location, the incident energy will now not be 5 cals per centimeter square, but it will be 25 cals per centimeter square. And in case if any incident happens and the person did not know about this factor, he will be seriously burned or he will be seriously injured in that arc flash accident. So that's why it is very important, and now it has become part of the requirement of the 70E is that you should carry out those maintenance requirement in order to check whether the device is opening and operating at a time which, for which it was designed, and the risk assessment was performed. So from the exam point of view, we have to also keep in mind that the incident energy is dependent on the available incident energy is dependent on the device clearance time, providing that the fault current is constant at that particular location. We can also see this graph from any other angle. Now I'm a consultant, and I have designed an electrical system. You people are basically my client. I have come to you people and have produced my design for approval. You identify as a CSP that at a particular location, the incident energy is 25 cals per centimeter square. From the HSEQ background and having a CSP credential, you know that this 25 cals per centimeter square incident energy is very dangerous. I think in Aramco as well as in other Australian companies, that from the design side, 8 cals per centimeter square of the incident energy is only allowed. If you are designing your electrical network with more than 8 cals per centimeter square of the incident energy, the design is not passed. So a consultant have to redesign their electrical network so that the incident energy is less than 8 cals per centimeter square, or maximum till 8 cals per centimeter square. So being a CSP, you will not going to approve those design because the incident energy is around 8 cals per centimeter square. You will going to check the device coordination and the clearance times, and you will going to ask your consultant to do the protection coordination and try to reduce this to a value, so that it won't be causing nuisance tripping to the network. The network is reliable, but the incident energy need to be lower. So uh, by this information, if you have this type of the information, you will ask your consultant to review their design and to design the equipment in such a way that the incident energy is around 8 cals per centimeter square or less than that. Similarly, for your existing plant, if you plan to initiate the incident energy, or if you plan to implement the NFPA 70, and you want to carry out this this incident energy analysis for your complete plant, uh, your consultant have performed the study, and have identified that these are the location at which there is a potential of reducing the incident energy from 40 cals per centimeter square to 8 cals per centimeter square or 5 cals per centimeter square, by only doing this device coordination properly. So by this, you can also reduce your incident energy for your brownfield project. So this chart can be understood in 3 ways. One is that you can use this explanation to make realize the maintenance people that the maintenance which they are doing have an impact. So if the equipment is not properly maintained, and it is taking more time for fault clearance, the incident energy at that particular location will increase many folds, and what the initial incident energy study was performed might not remain relevant. Second is that for the brownfield project, if you are a HSEQ manager for your own right now organization, and you want to carry out those studies, you can sit with the client, with your consultant confidently, and you can talk about that what are the options, what are the options they are suggesting to reduce the incident energy. They might be offering some expensive solution to reduce incident energy, but now you have this knowledge that the incident energy can be reduced if you are playing with the device clearance time. If they have marked the high device clearance time, that means the incident energy will be higher at that particular location, and they are advising you some other solution rather than playing with this device clearance time. And for the new project, which is new, so you can also play your part in the acceptance of those design, whether those equipment, or sorry, whether those electrical system which have been designed fulfills your requirement or not. Yes, any question on this one? Yes, please, if you have any questions.
No, sir. No.
Sir, for device clearance times, relay will work or no?
Yeah, both complete system from relay to the switchgear in order to open and clear the fault. For example, relay have worked, relay have given the signal, but the switchgear has stuck due to poor operation or mal-operation. So the ultimate target of clearing the fault is not achieved. Okay, let me share you this sample report of e-hazard. So at particular plant bus, which is operating at 480 volts, the the bolted fault current is 26.9 kiloampere. TK. Bus arcing fault and the protection device. The thing which we are observing here, trip delay time setting 0.025. So at 480 volts with the fault current of 26.9 with 26.9 and the device clearance time of 0.25, the incident energy at the working distance of 18 inches is 1.3 cals per centimeter square. Okay, and the arc flash boundary they have proposed to be 19 inches. On the same voltage level of 480 volts, if we go down for the same organization, 480 volts with the device clearance time of 2 seconds. Here it's in milliseconds. It's around 25 milliseconds or 0.025 seconds. If the device clearance time is 2 seconds for the same voltage level, the incident energy is 125 calories per centimeter square at the LV side, low voltage side. So if this type of the report comes to you and you analyze with your consultant, you will definitely ask why this incident energy is so dangerous. Okay, what we can do, just perform another simulation with different trip time settings and try to reduce it so that it won't cause nuisance tripping. Maybe he will going to reduce it to 1, then to other milliseconds. Okay, so as you are reducing it, this incident energy will going to reduce. So you can work with your consultant to reduce the incident energy available at in your particular organization. For a 22 kV system, if you are working here in the same organization, for a 22 kV system here in row number 25, you see that the incident energy is only 5.4 cals per centimeter square because the device clearance time is 0.017. So that shows how the device clearance time or the device tripping time or fault clearance time have an impact on the incident energy. Okay. This point is clear? It's not working.
Yes, sir.
Okay. Another thing which I want to discuss now. Just a second, what happened to it? What happened to it? Why it is not opening? Okay. Okay, let's see, it's a 480 volts. 480 volt system, and here they have calculated the arc flash boundary to be 19 inches. Okay, 19 inches. Refer to this table. For 480 volts, 480 volts will going to lie somewhere here. Okay, 480 in between. So here the limited approach boundary is 3 feet and 6 inches, and the restricted approach boundary is 1 feet. And the arc flash boundary is 19 inches. So that means the arc flash boundary will going to come within the limited approach boundary as well as within the restricted approach boundary. So this concept that the arc flash boundary will always be the outer boundary is not correct. Okay, from the table, we have seen that for this plant at a particular location, the arc flash boundary is 19 inches for 480 volts. Okay, so the arc flash boundary will be at 19 inches, and the limited approach boundary and the restricted approach boundary will be like this. It could be like for 220 volts, 22 kV system, it's 36 inches, and the restricted approach boundary and the limited approach boundary will be based on the voltage level. So this boundary can come in between the limited approach boundary and restricted approach boundary as well. Or this incident energy, if for example, this 125 cals per centimeter squared, it is 306. So just convert 306 inches into fits and inches. You will going to find that for this 480 volts now, the arc flash boundary will be the outermost, then the limited approach boundary and the restricted approach boundary. That's why I have mentioned you earlier that the limited approach boundary can come inside the arc flash boundary can come inside the restricted approach boundary, limited approach boundary, or it could be outermost boundary. This concept is clear?
Yes, sir.
Okay. Right. Moving to next one. The same scenario. Now the consultant have asked you to apply some methods in order to reduce the fault current. So what you will going to ask him? You will going to ask him to first play with the time settings. You have reduced the time duration. Now try to reduce the fault current by applying those thing which they are recommending. You will going to find that if by this playing with this time constant, you have already reduced the time level to that particular value at which the incident energy is minimum at that particular location. Now try to reduce the fault current will not have an impact on the incident energy. For example, if the fault current is around 90 kiloampere, and by method we have tried to reduce that fault current from 90 kiloampere to 20 kiloampere, the incident energy is here around 1 or 1.2 cals per centimeter square. It will have a minimum impact. Maybe after reducing current from 90 kiloampere to, for example, 20 kiloampere, the incident energy have reduced from 1.2 cals per centimeter square to 0 cals per centimeter square. So the impact of reducing the fault current is low on the overall system if you are playing well with the device clearance time. Okay. So this person is performing some thermography. This could be the outermost boundary, and it could be an arc flash boundary or the limited approach boundary, whichever is greater. He's wearing the right amount of PPs, which seems to be for above 24 cals per centimeter square, or it could be 40 cals per centimeter square, and he's performing thermography on the low voltage side. There is an attendant. He could be an unqualified person or an observer, or he could be a person who is undergoing a training requirement. So any unqualified person should be standing beyond the limited approach boundary or the arc flash boundary, whichever is the greater one. Here in this case, and a person is trying to operate an electrical equipment. She is the first aider and wearing an appropriate PP because she won't be performing the live job. So she's wearing ear protection, because in case of arc flash or arc blast, there will be sound waves greater than 100 decibel. She is wearing personal protective equipment of arc rated PPs. and having those extinguisher with her, and standing outside the limited approach boundary or the R flash boundary, whichever is greater, or this is a barricade area. This barricadation could be equal to limited approach boundary or the R flash boundary, whichever is greater, or this barricade area could be outside those boundaries requirement as well. So another method, first method we have seen to calculate the incident energy is by the calculation method. Okay, so we are using software, we are using advanced methodology in which we are doing simulation. There is another method given in the standard in table 130.7 C15A, which is about the R flash PP category method. So in this R flash PP category method, it does not provide you the incident energy value, but it directly recommend you what PP category you should wear, and the PP category indirectly have those incident energy built in when in calculation of those PP category. In this PP category method, in the first column, you will going to find there is an equipment description given and the parameters given. So the equipment is panel board or other equipment rated at 240 volts. What are the parameters given? Maximum 225, maximum 25 kiloampere fault current. Clearance time is 0.03 seconds or 2 cycles, and the minimum working distance is 18 inches. So if this condition is completely meet, then you can use an R flash PP category of 1, and R flash boundary can be determined to be 19 inches. If any of these conditions are not met, we cannot use this information. For example, in my industry, the panel board and other equipment is operating at 240 volts. The maximum available fault current in my industry is 30 kiloampere. So I cannot use it because here they says that the maximum available current should be 25 kiloampere. In my industry, the maximum available fault current is 20 kiloampere. I can use it because 20 kiloampere is within that 25 kiloampere maximum value. My device clearance time is 0.03 second. I can use it. If my device clearance time is less than 0.03 seconds, I can also use it. But if my device clearance time is greater than 0.03 seconds or 2 cycle, I cannot use this one. If I'm working at a working distance of 24 inches, 36 inches, I can use it. But if I am working at a working distance of less than 18 inches, I cannot use it. So one of the drawback of this PP category method is that the equipments and the parameter should meet the requirement which are stated here. If not, you cannot use this table. For example, here my voltage level is 600 volts. I will going to search, okay, is there any panel board with 600 volts? Okay, yeah, there is a 600 volts given. So I will going to use this row number 2 if other parameters are same. For 1 kV, I cannot use because panel board and other equipment rated at 1 kV are not given in this PP category method. Then I have to go towards the incident energy analysis method to know what the value of the what actually is there, and how what will be the incident energy, and what will be the R flash boundary, and what is the rated of the PP we have to use. Okay, so this is basically the drawback of the PP category method. Any question on this one?
No, sir.
No.
Okay, just a second, please. Things clear up till now? So this is the method which we talk about, the incident energy analysis method. It basically based on IEEE 1584 2018, and it's a software-based solutions. So this is now your limits of approach, informative annexure C, limits of approach, self-reading assignment. You have to read yourself about the limited approach boundary and the restricted approach boundary and the R-flash boundary. So what is given in the informative annexure C, I'm just going through it quickly. Observing a safe approach distance from exposed energized electric conductor or circuit parts is an effective means of maintaining electrical safety. As the distance between the person and the exposed energized conductor or circuit part decreases, the potential for electrical incidents increases. The unqualified persons are safe when they maintain a distance from exposed energized conductor or circuit part, including the longest conductive objective being handled, so that they cannot contact or enter a specified air insulation distance to expose energized electric conductor or circuit part. This safe approach distance is the limited approach boundary. So basically this limited approach boundary triggers for unqualified person. It also triggers for longest conductive objects which are being handled. Further, person must not cross an R-flash boundary unless they are wearing an appropriate personal protective clothing and are under the close supervision of a qualified person. So here they say that an unqualified person can cross an R-flash boundary, but they need to wear an appropriate personal protective equipment PP rated for that incident energy level. And he is under the close supervision of a qualified person. So here it does not say that an unqualified person can perform work within the R-flash boundary. Is not allowed. An unqualified person cannot perform work within the limited approach boundary, and he cannot perform work within the R-flash boundary as well. Only the crossing of those R-flash boundary and the limited approach boundary is allowed under the supervision. Only when continuously escorted by a qualified person should an unqualified person cross the limited approach boundary. Under no circumstances should an unqualified person crosses the restricted approach boundary where special protection techniques and equipments are required. So this is for the unqualified person, and it covers all three types of the boundary: limited approach boundary, restricted approach boundary, and the R-flash boundary. For the qualified person, for a person to cross a limited approach boundary and to enter the limited space, a person should meet the following criteria. He should be qualified to perform the task. He should be a qualified person. He should be able to identify the hazard and the associated risk with the task to be performed. To cross the restricted approach boundary and enter the restricted space, a qualified person should meet the following criteria. As applicable, should have an energized electric work permit, be authorized by the management. As applicable, they are mentioning. As we will move on, we will see that the energized electric work permit is not mandatory requirement for some type of jobs. For example, if you are performing thermography, testing, troubleshooting, measurement, those tasks are exempted in 70 from completing an energized electric work permit. So you should do energized electric work permit or not. That thing we will discuss when we will be in module number 3 and 4. So as applicable, when have an energized electric work permit authorized by the management. So if it's working some repair, replace, or any other task, you should have an energized electric work permit. Use protective equipment that is rated for the voltage and the energy level involved. So if he is working within the restricted approach boundary and the R-flash boundary is greater than the restricted approach boundary, so he will be wearing personal protective equipment. We will be having he will be wearing personal protective equipment for voltage and energy level involved. Minimize the likelihood of the bodily contact with exposed energized conductors and circuit parts from an inadvertent movement by keeping as much as of the body out of the restricted space as possible and using only protected body parts in space necessary to accomplish those works. use insulated tools and equipment. So he should be using those insulated tools and equipment. So these are the things you will going to find when you will be reading those annexures C. Okay, so this person is trying to open an enclosure. When this enclosure is open, this person will going to find himself within the inside the shock protection boundary as also within the arc flash boundary. The employee will be inside the shock protection boundary as well as within the arc flash boundary. In addition, the employee is interacting with equipment in a manner that increase exposure to an arc flash hazard. So he is already wearing all the PPs rated for the incident energy as well as for the voltage level. Right. Any questions up till now?
No, sir.
Okay, in exam, you will going to find these type of the questions. For example, they have asked you a panel board or other equipment which is operating at 240 volts and 600 volts. They have given you the maximum fault current cycles, etc. and they are asking about the limited approach boundary and the restricted approach boundary. Okay, so in this particular case, we know that this information is not relevant when we are calculating the limited approach boundary and the restricted approach boundary. We have to deal with the voltage, and they have given us the two voltage range, 240 to 600 volt. So if we look into 240 to 600 volts, that is falling under this range, and the bus bar is fixed. So the limited approach boundary will be 3 feet and 6 inches, and the restricted approach boundary will be 1 feet. If in case the range was from 240 volts to 1 kV, so we will be using the highest voltage level. So 1 kV voltage will be would be falling under this range. So we will be giving answer that the limited approach boundary will be 5 feet and the restricted approach boundary will be 2 feet. But in this case, the 240 to 600 volt is within this range. We will be giving answer 3 feet and 6 inches and 1 feet. So other information is not relevant when we are calculating the limited approach boundary and the restricted approach boundary. Okay. But if it is also asking you to calculate, okay, if it is also asking for the PP category, then we will refer to 130.7 C15A table, and from there we will check which row is exactly matching. And if it is matching exactly 240 and 600, we have seen the example before that was a PP category 2. We will go to select the PP category 2 here, and the arc flash boundary. The arc flash boundary is also given on the rightmost column, and which is 3 feet. Okay. If this condition does not present in this table, there would be one answer in the question given, that you cannot calculate the PP category and the arc flash boundary because the information provided is not sufficient. So we know that if the parameters or the equipment details are not matching 100% or exactly, then we have to perform incident energy analysis. Okay, any question on this one up till now?
Sir, 2 cycles for clearing time means what? Cycles.
Basically, it is the fault clearance time. So you can talk about in seconds or in cycles.
Okay, sir.
Okay, let's do some Q&A for this topic, the shock protection boundaries are independent of an arc flash boundary. Yeah, it's true. The shock protection boundaries are independent of the arc flash boundary. An arc flash boundary may be thought of coming into existence when a person is interacting with electrical equipment in other than norm. So in exam, there won't be any true and false. These questions I have only put for the knowledge check and just to consolidate that you have absorbed the concept. Yeah. So the arc flash boundary may be thought of coming uh, into existence when a person is interacting with electrical equipment in other than normal operating condition. Yeah, if a person is coming in contact in under normal operating condition, so there is no chances of arc flash is there because the arc flash hazard does not exist. So in other than normal like operating condition, this exists. So the answer is true. The arc flash boundary is independent of shock protection boundary, shock protection limited approach, and the restricted approach boundary. This is true. The arc flash boundary is independent of the shock protection limited approach boundary and the restricted approach boundary. The question is similar that what we had discussed, that the arc flash boundary is independent of the shock protection boundary, and within the shock protection boundary, within the shock protection boundary, we have the limited approach boundary and the restricted approach boundary. The R flash boundary may be greater than, less than, or equal to the limited and the restricted approach boundary. What's your opinion on this one? It's not asking about maintenance at the time right now. It is only asking the R flash boundary may be greater, less than, or equal to the limited approach boundary or not. So answer is yes. So whether you are performing maintenance, you are performing inspection. No, this is a concept Mubina, we have just discussed that it could be less than the limited approach boundary and the restricted approach boundary. I have shown, okay, in this one, in the sample report, I try to explain that for this one, the voltage is 480 volts. The R flash boundary is 19 inches. Okay, 480 volts. 480 volts falls here. The limited approach boundary is 3 feet and 6 inches, and the restricted approach boundary is 1 feet. So it can fall under the so 19 inches will come within those fits as well. So it can come within the restricted approach boundary for certain cases. For example, if it is more lesser than this than 19 inches, it could be 10 inches or it could be 5 inches. So there is a chance that the arc flash boundary can come within the limited approach boundary and the restricted approach boundary. So the R flash boundary may be greater, which we normally know that R flash boundary is always greater. It can be less than or it can be equal to restricted, and because those boundaries are independent of each other. The limited approach boundary and restricted approach boundary is dependent on the voltage level, while the R flash boundary is dependent on voltage level, but it is more dependent on the amount of available fault current and the fault clearance time. The restricted approach shock protection boundary is the approach limit for qualified employees. Yeah, this boundary is for the restricted approach shock protection boundary is the approach limit for the qualified employee. This is the right option. When an R flash hazard exists, an R flash boundary is. What's your opinion? Yeah, B is the right option. Is the distance at which the second degree burn can happen on the unprotected skin. The limited approach is the distance at which these four type of the options which I'm showing, those are part of the exam question, or could become part of the exam questions. So the right answer is a shock hazard exists. B is the right answer. So the limited approach boundary is for shock hazard. There is an increased likelihood of electric shock. This is basically linked with the restricted approach boundary. So the limited approach boundary is the distance at which the shock hazard exists. Restricted approach boundary is the distance at which there is an increased likelihood of electric shock. Okay. Moving to next one, which of the following statements about unqualified person is true? So these type of the question you will going to find in exam, which will be much tougher because they will be wordy. And the statement could be from one chapter, one section, one article, or it could be from different. So you have to read the statement individually and have to answer accordingly. So which of the following statement about unqualified person is true? So there will be more than one options could be correct. Okay, so what are the answers? Don't know. Give it a try. Read again and again for next 30 seconds and try. Okay, let's review the answer. An unqualified person must be escorted by a qualified person within the restricted approach boundary. This is wrong because an unqualified person cannot enter the restricted approach boundary. So this is not the right option. Moving to B, an unqualified person must be escorted by a qualified person within the limited approach boundary. Yes, this is right. B is the right. An unqualified person may be unsupervised within the limited approach boundary provided they are not performing job. No, this is wrong. They cannot remain unsupervised. An unqualified person may be unsupervised within an ARF-Kalaj boundary without the PP provided they are not performing job. So unqualified person cannot remain unsupervised within the ARF-Kalaj boundary. So only B is the right option. Okay, any question on this one, or this is clear?
Sir, what is the right answer?
B, an unqualified person must be escorted by a qualified person within the limited approach boundary. All options are wrong. So in exam, you could have more than one answer time. Okay. Moving to next one. The arc-Kalaj boundary is okay. What's the right answer? Let's see. D is the wrong answer. C is the right one. An R-Flash boundary may be farther than the restricted approach boundary because is the distance at which the incident energy is equal to 1.2 cals per centimeter square would be right. But here it says 1.5 cals per centimeter square. So that's why this is wrong option. Option number C is right. Maybe farther than the restricted approach boundary. Yes, we have discussed that the R-Flash boundary could be greater than the restricted approach boundary. Okay, any question or any confusion up till now? Now let's see about the working distance. There is a definition given the working distance. It is the distance between the person face and a chest to the perspective R source. So this is basically the horizontal distance to the person chest or the person face. This is called the working distance. This working distance is very important. We have seen in the incident energy analysis as well as in the PP category method, both talks about the working distance. So why it is important? Let's see from one of the same studies. For example, if at this particular R source and an R flash incident happens, so the incident energy could be 40 cals per centimeter square. As we increase the distance, the incident energy starts to decrease, and at a particular distance, the incident energy comes to 1.2 cals per centimeter square. So this is the point 1.2 cals per centimeter square, which is termed as an arc-Kalaj boundary. Okay, so it reduces over the period of time, and eventually it becomes 1.2 cals per centimeter square. That means the incident energy will going to decrease over the distance. So if we are being able to increase the working distance, the incident energy will be reduced, and if we decrease this working distance, the incident energy will be increased. For example, I was assigned, I had performed my risk assessment and have come out that at the working distance should be minimum of 36 inches or 24 inches. So I calculated at the 34 or 36 inches working distance, the incident energy will be 10 cals per centimeter square. But my qualified employees does not know about the importance of the working distance. They approach more closer to the electrical equipment and installation in order to perform the task. So based on the 36 inches working distance, the incident energy was 10 cals per centimeter square, and they were wearing personal protective equipment PPs of 12 cals per centimeter square or 20 cals per centimeter square. But they approach more closer, and the working distance was reduced from, sorry, here the working distance is let's go 55 inches. They reduced the working distance from 50 then to 24 inches. So at that particular location, now the incident energy will be around 30 cals per centimeter square. Without they know that the incident energy which they will going to receive now at the working distance of 24 inches or 36 inches will be approximately 30 cals per centimeter square, as opposed to if the working distance was meant to be maintained at 55 inches, the incident energy was 10 cals per centimeter square. So the PPs which he was wearing for performance of the same job at the 55 inches won't be able to save him if any R flash event occurs. So this is the importance of the working distance. At a particular location, if a person is working at 18 inches, the incident energy is 50 cals per centimeter square. But now I've been able to increase the working distance from 18 inches, let's suppose 100 inches. Now the incident energy will decrease from 50 cals per centimeter square to less than 5 cals per centimeter square or 4 cals per centimeter square. It's nearly equal to zero. So that's why there are different type of the tricks are being used, like it is said that if you need to verify for the absence of voltage, use long handle testers at the high voltage. So the greater the distance you are being able to create, the lesser the incident energy will be there. And if you are going more closer to the equipment or energized part, the incident energy will be higher in that particular case. So in exam, they will going to test your knowledge about this change in the working distance. This basically comes under the scope change. For example, I had initially given a task of performing a thermography at a working distance of 36 inches. I performed the risk assessment, and the incident energy was around 8 cals per centimeter square. I was wearing 10 to 12 cals per centimeter square suit. During the thermography, I identified that there is some loose connection. Now, can a qualified person can perform those repair work because the loose connection is there? So can I tight that connection because there was a hot spot was showing? So it's not allowed because it will going to come under the scope change. You are reducing the working distance from 36 inches to maybe 18 inches. So the PPs which you are wearing to perform the thermography might not be suitable to perform that particular task, and also you might not be qualified person to perform that repair task or the replace task. So you have to eventually pass on this job to as a new job. A new risk assessment will be performed, and the PPs and the other things will be selected accordingly related to the task in hand now. So that will going to fall under the scope change. So there you will going to find number of questions in exam related to this concept of working distance and the scope change. Just keep in mind that the risk assessment is being performed for a particular working distance. That's why I have shown you in the incident energy analysis method, there is a working distance given, as well as in the PP category table method, the PP is being selected based on the working distance. So if the working distance is not followed, all your risk assessment will be null and void. Any question on this one, on this concept?
Excuse me, sir.
Yeah, please.
Sometimes they say like for monitoring and testing such kind of things, there is like some different instructions. So now we are talking about that. Just want to understand. For example, taking a thermography reading. Is it any? So we are inside the distance, or we are in that. We are in the boundary, so we need to be protected in whatever we are doing, right? Even we are idle or whatever.
I did not understand the question.
I said sometimes, like in the basic definitions, they say that like there are some exemptions that if you are monitoring and all that, and then the criteria is different. And if there is a work any, that is something.
Yeah,
Yeah.
Yani that is basically the scope change. No, if you are given a task of this one of performing those studies, sorry, those thermography and other thing. So you can perform those things, but you are not allowed to perform any other task until and unless you are not qualified for it.
Mhm.
So that comes under the scope change.
Okay, so qualification is different, but we are talking here about the clearance, right? About the protection.
Maybe that person is not qualified to perform a repair and the replace task. He is only qualified to perform inspection, condition monitoring.
Uh-huh.
Or second thing is that if a person is qualified for both the tasks, but initially the risk assessment identify that he will going to perform only condition monitoring at a working distance of 36 inches. Now during that thing, he identified that there is a loose connection. He's qualified
Okay.
to perform this, but he's not wearing appropriate PP to perform that task at a working distance of less than 36 inches.
So the hazard is increased. That means that now he need to be protected.
Yeah, the
right?
risk associated with that particular hazard is increased. So a new risk assessment need to be performed. If during the risk assessment, it was already defined that you will going to perform the thermography, visual inspection, or condition monitoring using any electrical equipment, uh, any test instrument, and you identify any abnormality, you will going to rectify it. So this was a complete work scope. So if that was a complete work scope, so the PPs were selected based on the minimum distance he will be required to perform any task during this scope. So it was already identified that this person will be performing life work at a minimum working distance of 36 inches, at a minimum distance of 18 inches. So the PPs which he was wearing was rated for that particular voltage level. So he's allowed to perform task as well, until and unless that task is already justified to be performed on the live. There could be scenario that you have performed an inspection, you at a 36 inches by wearing a PP of 10 cals per centimeter square. Now you raise that there is some rectification work need to be performed. So that work does not fall under the exemption criteria of Article 110.4. So you will be establishing an electrically safe work condition to come and perform that repair or the replace task. So once an electrically safe work condition is created, there is no hazard there. The arc flash boundary, shock protection boundary does not exist. The arc flash hazard, shock hazard does not exist. You can come and work without wearing the appropriate PP, without wearing those PP which is used which is required when you have to perform work on the live system. All these scenarios are clear?
Yes, sir. Yes, sir. So I have another question.
Yeah, sure.
I have something with our headlines. Okay, so like, considering the arc flash, like the whole subject, for the hour head, like as we said, the distance is like axial distance. The chest and the equipment. Like, so what in case of our headlines like with the poles, transformers, and the lines for
So
the
for
arc.
example, so for in that particular case, if a person is trying to verify the absence of voltage at the overhead pole, so he might be in the horizontal distance with the overhead line while confirming, or he might be at the bottom level or below the overhead line in when he's testing the absence of voltage, or he's doing those shortened grounding. So this will be the distance in that particular case. That will be a slightly vertical or slightly angular distance, which need to be maintained. So if you are working on the same floor length, so this working distance will be the horizontal distance. Otherwise it could be an angular distance which you need to maintain in that particular case as well.
Okay, sir.
Right. Any further questions on this one? Okay, let's do one question and then we will going to close the session for today. The required arc flash PP is based on incident energy at the arc flash boundary. What's your opinion on this one? So in exam, they will going to ask this question by using scenarios. Okay, so it won't be true and false. I've put true and false just to clarify things. They will be saying that Mr. James need to select his personal protective equipment to perform a job at particular location where the incident energy at the working distance is 40 cals per centimeter square. And at the arc flash boundary, the incident energy is 1.2 cals per centimeter square. So he has selected an arc flash PP based on the arc flash boundary. So the answer will be false. So here the answer is false. The required PP is selected based on incident energy at the working distance, not at the arc flash boundary. Because at the arc flash boundary, the incident energy will always be 1.2 cals per centimeter square. But if you are changing the working distance, the incident energy will going to change and the PP will going to be changed. So the personal protective equipment are always selected based on the incident energy at the working distance. Okay. Any confusion or any clarification is required in this one? All good. Right. Thank you all for joining. And now we will be catching you people on Wednesday.
Sir, I wanted to ask for the study material other than 70E.
Okay.
Uh,
I will check with Mr. Salahuddin how we will going to transfer.
Yeah, I
Okay.
want to catch up with the today's session. I was in travel.
Okay.
So,
Sure.
thank you.
I will discuss with him and we'll going to sort out on this weekend.
Thank you, sir. Thank you so
Okay.
much.
Thanks a lot. Thank you. Thank you all for joining. See you on Wednesday, inshallah. Thank you. Bye.